Well, today we're talking about struck by hazards and caught in between hazards. So, yes, we're going to be dealing with describing struck by hazards and how to avoid them. We'll describe common caught in and caught between hazards and steps that can help prevent them. A couple of trade terms. A signaler is a person who's responsible for directing a vehicle when the driver's vision is blocked in any way. And that doesn't just mean vehicles like cars and trucks. It also means heavy equipment. It's particularly what it means when we're dealing with construction. Shoring is a support system. It's a built-in place support system designed to prevent a trench or an excavation to collapse. Meanwhile, shielding is a structure, a prefab structure, really, used to protect workers in trenches. So they do a similar thing, but they do have different terminology. So a trench shield is also sometimes called a trench box, whereas shoring, we're talking about built-in place structures, typically designed individually, each one by a structural engineer. Now, the last term, spoil. Well, spoils is what you divide up after the bank robbery, right? No, this is a different term or different use of that term. Spoil is the material that you dig up out of an excavation and pile up nearby. And so a big pile of dirt is a spoil. So materials such as the earth removed while digging a trench or an excavation. And of course, you have to keep them far enough away from the edge of the excavation so it doesn't cause the trench to collapse and so that no chunks or pieces or parts of the material fall into the trench. Okay, so let's move along here. First of all, OSHA has this term where they talk about the fatal four, the top four things that kill people on a construction site. So a gruesome topic, yes, I know. So the greatest one by far, the largest number of fatalities comes from falls. From elevation, typically, but falls nonetheless. It involves gravity. The second one is one of our topics today, and it's struck by hazards. It's the second leading cause of fatalities on a construction site. Struck bys involve forcible contact. A very close third, and sometimes it's second and struck bys are third, but most of the time electrocution. Being electrocuted would be considered, when it's a fatality, is a third leading cause, but it's very close behind. They're often neck and neck. And then a somewhat distant fourth leading cause of fatalities on a construction site is the caught in or caught between. So the two in boldface on this page, the struck bys and the caught in / caught betweens, are what we're dealing with here today. We deal with falls and electrocution in other topics here. But today it's struck bys and caught in betweens. Okay, so what is a struck by hazard? According to OSHA, struck is defined as injuries produced by forcible contact. So a struck by hazard it involves things like what you see in these four bullets here, struck by flying objects, maybe flying at your face, flying at your body. You can be hit, impaled by shrapnel from an explosion, from a grinding wheel coming apart, that sort of thing. The struck by falling objects, something falling off a roof, or something falling off of some other high elevation could certainly be a struck by falling object. Struck by swinging objects, you could have slings on the end of a crane that are loose and not attached to an object, and they can be swinging around and smack you. Or just the object itself. If the crane is swinging around, it could smack you. You could also have a track hoe, for instance, that's swinging around to grab some more dirt from one side and doesn't realize you're standing right there and smacks you. So that would be a struck by. Struck by a rolling object. Okay, so again, the second leading cause of construction fatalities, you need to remember that, is the struck by hazards. Okay, so here's some examples. Being hit by flying debris from a grinding wheel. Okay, I kind of led with that earlier here a moment ago, but getting struck in the head by a carpenter square that fell off a roof. Getting slapped in by the load as it swings or turns, or by the swinging shackles. Okay, I kind of described that a moment ago too. Being run over by a 5-foot diameter rolling pipe. Oh my goodness, that would be something. But yeah, so there's velocity involved generally with struck bys. So the struck by hazard, the last bullet here, can be described as any time a worker is hit by a falling, swinging, flying, or rolling object. Okay. The applicable OSHA standard depends on the nature of the strike. But in general, we choose the most prominent activity involved. So if the hit involves significant velocity, it's typically going to be classified as a struck by. Now that said, there are a few gray areas where sometimes we get things that are considered caught in or caught between. So we'll come to that in a minute. But the last bullet here, struck by injuries are produced by forcible contact. So that's a very good description, those two words, forcible contact or impact between the injured person and an object or a piece of equipment. Okay, workers are at risk when they're beneath machinery and equipment, overhead, such as cranes or loads that are being picked up by cranes. If you're walking underneath scaffolding, you're at risk. Where there's overhead work being performed, when working around stacked materials that can fall off the stack and get you, or the whole stack can come over on you. So again, we typically, for elevation particularly, and falls of things falling on you or striking you, a hard hat can help. The safety glasses can help when you're talking about something that can strike your eyes, and things that can strike your hands. The gloves can help. And work boots. So the PPE, the personal protective equipment we wear, is a big part of how we protect people. But that's not the only way. That's a last line of defense. The first line of defense is to make sure that the thing didn't even fall, or that it doesn't fly, that it doesn't strike anybody to begin with. Okay, so here we got a person working up on a roof. And they really should, if they're going to have people working below, you've got to zone off the area that you're working at. You should never have anybody working directly below you. And you say, well, they're not directly below. Yeah, but you've got that roof that is going to change direction of anything that you drop. So if you drop your caulking gun or your hammer, it's going to come out and has a potential to strike somebody. So you can never work at elevation with somebody else working below you without them being protected. So generally, you zone out that area with red danger tape or barricades to keep people from even being in that area while you're working up above. So, yeah, no head protection. So at least a hard hat would help. But yeah, no head protection, exposed to struck by hazards from falling objects. Let's look at this one. This is a concrete slab. It's about an 8-inch thick, maybe 20 foot by 8 foot. It weighs about 16,000 pounds. And it can swing. And this guy kind of in the middle of the picture in the gray jacket is in a precarious position, maybe even the person on the right-hand side too, because if you can be pinned between the crane, you don't really have anywhere to run, and so you should never put yourself in a position like this guy is at. What you do when you have to guide a load is you tie ropes to this. So it says here, stay clear of loads that are suspended or about to be suspended, which creates struck by hazards from falling, or in this case, probably a swinging object. If control of the load by a worker is necessary, then you use a tag line. That's what you do. When you tie a rope, we call it a tag line. And so the person actually hanging on to that rope, we call them a tag line tender, that they're tending the line. Okay, a little bit of vocabulary there. So then the flying objects, you use eye protection, such as safety glasses, goggles, face shields, usually in combination, where machines or tools may cause flying particles. You inspect the tools and machines to make sure their protective guards are in place and in good condition. For instance, this picture of this angle grinder here in the upper photo, you need to direct that guard that's over on the right-hand side of the tool right now differently if you're left-handed. Typically you have to take the disc off in order to reposition that guard in a different angle. But you need to have it set correctly depending on whether you're right-handed and left-handed and how you're using the tool. Let's see. Make sure that you're trained in properly operating any of these tools that can cause flying objects, whether they be pneumatically powered or powder-actuated tools. I'll show you an example of a powder-actuated tool in a moment here. using various shielding devices, maybe a welding screen or similar equipment to block the debris from other people in the area, because you got to protect not just the person working, but anybody that's adjacent to the hazard, anybody nearby. So here we've got somebody using a chop saw. He's got a metal cutting blade, and he's cutting some metal studs, actually, metal framing parts. Now he's wearing a face shield, so that's good. And there's a guard on the saw that helps keep the flying debris from flying toward you. But this stuff tends to bounce around, and it can still get you. And so the thing is about a face shield is it only protects your face. It doesn't protect your eyes. You can still have embers, fibers, flying debris that hits your chest and bounces to the backside of the shield. So you have to be wearing goggles behind that. So that's basically what OSHA is saying here. Grinding or striking material can create flying object hazards. This worker is protected by equipment, guarding, and face shield, but should also have safety goggles / safety glasses. The goggles are far better, and if you know there's a chance of something flying like this, you shouldn't just be wearing glasses, safety glasses. You need the goggles to give you better protection from the sides. And then this person here on the right-hand side is shooting a fastener into the wall using a powder-actuated fastener. And that's basically a gunpowder-powered tool, basically a glorified handgun that shoots a fastener into the steel, into the concrete, depending on what you're shooting. And meanwhile, there's somebody on the other side of that wall. So if this thing goes through that wall, instead of just fastening, it's going to strike that person. So that's what they're talking about. Here's a hazard. Powder-actuated tools can create flying objects struck by hazards. Never drive into easily penetratable materials when workers are on the other side. And you actually need to zone out the whole region when you're using a tool like this for safety, because you can have ricochets too. Vehicle and roadway hazards. Stay alert at all times. If you're working on a road, doing some kind of construction work on a road or near a road, keep a safe distance from vehicles and all equipment. The most common problem in doing road construction is getting run over by heavy equipment or other vehicles that are passing through. So you maintain eye contact with vehicle or equipment operators to ensure that they see you, because that communication means a lot. Never get into a blind spot of the equipment operator where they can't see you, because they can forget you're there. Keep off equipment unless you're authorized to be there. And then here's an important one. Wear reflective or high visibility vests or other suitable garments that make you visible, because that's an important safety feature of reflective clothing, is that then people see you and they remember you're there and such. Never stand between pieces of equipment unless they are secured. You can get pinned. Never stand underneath loads by lifting or digging equipment or near vehicles being loaded or unloaded. When a vehicle is operating indoors in particular, or in enclosed areas of any kind like that, carbon monoxide can be a problem with vehicles. Even fairly clean burning vehicles, clean burning fuels like propane are safer, but they still produce carbon monoxide, just not as bad as a gasoline powered engine would. And of course, unless you've got the ventilation, so of course you can address this with the ventilation, but it's often a reason that we use propane-powered forklifts indoors, but they still can produce some carbon monoxide, but a gasoline-powered engine and diesel-powered engines are much greater offenders on this. Carbon monoxide is especially dangerous because you can't see it, you can't smell it, you can't taste it, so it's dangerous. It'll sneak up on you and cause brain damage, can literally over time make you go to sleep if given the opportunity. Operating a vehicle or a generator or any other machinery with internal combustion engines indoors is very dangerous. Ensure that there's good ventilation before operating any motorized vehicle or equipment. Okay, here's a visibility issue, and you see there's two people in this picture, the operator up in the seat up top, and then just to the right of him, off a little bit off in the distance, there's a guy with kind of a pale blue shirt. And so, yeah, you can see him if you look for him carefully, but you can miss him. So reflective clothing would have made a huge difference here. The operator maybe sees him because he's in front. If he's on the sides or in behind, When they look back, they're less likely to see you. So highway construction workers need to wear high visibility reflective clothing to help prevent struck-by hazards from moving heavy equipment. Here we've got a guy with a gray face. Well, because OSHA didn't have permission when they took this picture to get his picture. But anyways, he's standing, probably waiting for the operator to call on him to go and maybe check something out, or to maybe take a grade measurement with a surveying rod. But he's within the swing radius of this track hoe. And so the operator could forget you're there. Slightly out of visibility, looks like he's wearing hearing protection, so that could affect his visibility too. So that's what OSHA is complaining about here, is it avoids struck-by hazards by not working within the swing radius of heavy equipment. You stay out of their reach and come in. Oh yeah, you have to walk a little bit more to get to where you need to be, but it's worth it. Okay, so now that's dealing with some of the struck-bys. Now let's look at the caught in, caught between category. So yes, we use this phrase, and it's a clumsy thing, but caught in / between, but it's really about you get caught in material, or caught in the gears of rotating shafts and that sort of thing, or you get caught between two objects. So sometimes they slang it as just caught in between, but it's the full phrase is caught in or caught between for this particular hazard. And again, down at the very bottom, last bullet, it says this is the fourth leading cause. So that's an important factoid to remember. Just going up one more bullet above, it says injuries resulting from a person being squeezed or caught or crushed or pinched or compressed between two or more objects or between parts of a single object. Okay, so examples. The examples always help. It says being trapped between a wall and the pivoting counterweight of a crane, which tends to stick out beyond the back of the crane, and so it's more likely to pin you. The next bullet, getting tangled within the gears of machinery or pulleys, gears and pulleys and stuff, being tangled up in rotating shafts of any kind. So drill press can be a problem if you got a rotating path, or a pump shaft. Your clothing can get tangled up, your hair. There's the gloves, depending on what kind of gloves you're wearing usually. The next bullet, being caught between the doors of a freight elevator as they're closing it. The last one actually deals directly with hair. It says getting hair, gloves, or clothing caught in or wrapped around the rotating shaft of a drill press or pulleys. And then there's pinch points on certain kinds of tools, especially at where the pulley meets the wheel of the pulley and the belt, where that can grab hair or clothing and that sort of thing. So we have to use proper guarding to protect you from that. So what you have to make sure is you're not using any equipment that's supposed to have a guard to protect you without that guard installed. Okay, so the struck by versus the caught in betweens. Sometimes it can be difficult to determine which circumstance, in certain circumstances, what wins. Do you call it a struck by hazard or a caught in or caught between hazard? So I say, first of all, if the hit involves significant velocity, forceful contact, like I said, forcible contact, it will be classified as a struck by. But even if there's velocity, like a fast rotating shaft or rotating gears and pulley, if it's a rotating shaft or rotating gears or pulley, it will definitely still be called a caught in, caught between. So that's a kind of helps to divide out the gray areas between those two categories. So you can have questions that you got to figure out. Is it a struck by or a caught in between? And this is a particularly important page for helping you with that. So remember, significant velocity or forceful contact, then yes, it's a struck by, unless it involves rotating shafts, rotating gears, and pulleys. So, but if you had, let's say, a stack of drywall leaned straight up and down on a wall, and you start flipping through it, and then you lose control, and the whole stack comes your way and pins you, that's considered a caught in, caught between, because you're trapped by it. If you're in a trench and the trench collapses and buries you partially, that is a caught in or caught between, as opposed to a struck by. Unless the main injury comes instead of from that, but if you're not really pinned, but you're struck by, let's say, a chunk of concrete that slides down the trench, then it might still be called a struck by. Okay, so here we're looking at trenches for a moment. So just 2 or 3 feet of soil can put enough pressure on your lungs and your chest when you're buried up to your chest to prevent you from breathing. So you're in a very serious situation if you're buried up to your chest in any way. So that's a particular problem. It's actually a serious condition even to be buried up to your hips because it stops the flow of blood properly through your legs, and it can take quite a while to rescue somebody in a trench. I want to try to avoid from spending too much time talking about trenches, but they are typically an area where we deal with the caught between hazards. We deal with trenches and excavations in other areas here. But, so yeah, he's showing you some things about how we protect people. You can either have a sloped trench, you slope the trench walls, depending on what soil type you have. You can bench it if it's a good enough quality soil, type B and type A soil. If you're looking back at this table here, type A is better than B, which is better than C. So in type A and B soils, you can do benching, but you cannot do benching if it's type C soil. It has to be sloped. Or you build a shoring system, or you use a trench shield, a trench box. So a trench shield or a trench box, we're kind of showing a picture in a cartoon on the left and an actual picture on the right, where it's showing a very big shoring system here. You can't just drop actually it's a big trench box or a trench shield system. What I would just mention is that you can't install a trench box, trench shield without it being backfilled on both sides because it can move sideways and mow over your legs. Okay, so you see this hazard here? Well, actually, in this case, it looks like it's a big chunk of concrete or a big chunk of rock, something we wouldn't have in Louisiana in our soil. So that's a problem. But there's no shoring here. So yeah, they got a big boulder, so that could be a struck by when it hits you, but the fact that there's no shoring in here. So one of the things about excavations, and I guess I should mention that here, even though it's not specifically about excavations in this section, is that with excavations, if you've got an excavation of any kind that's more than 4 feet deep, you have to have egress. You have to have ladders and exit within 25 feet of you. So that's a 4-foot rule for excavations and trenches. Trench is just a special kind of excavation. That's narrower. It's deeper than it is wide. But you also have to realize that you're at 5 feet. We have another rule for excavations. A 5-foot rule is you must have shoring or sloping or a trench box to protect you. And he doesn't have any of these things. So no protective system. So when we talk about protective systems, we're generally talking about shoring. So here's a trench with no shoring. So it's deeper than it is wide. And once it's wider than 15 feet, we stop calling it a trench no matter what. This is definitely a trench. And this guy has a ladder at one end, but not at the other. So when he's down at the other end, he's bound to be at least 25 feet away. So that's a problem. He needs another ladder at the other end, or he needs one in the middle, or something so that he's always within 25 feet of a ladder. Second thing is there's no shoring or sloping going on here. And it's definitely more than 4 feet. So he needed the ladders. It's definitely more than 5 feet. So he needs the shoring or the sloping. And the sloping would be kind of hard to do here because you could undermine that foundation of that building, which is also likely to cause the trench to collapse because you got the weight of that building putting load on the soil. So he's got a lot of issues. And oh, by the way, OSHA is going to measure the depth of your trench by the top of that spoil pile. So that's one of the problems when you put the dirt right next to the trench. You artificially increase the depth of the trench. So workers in unprotected vertical wall trench, they're putting in pipe in the bottom of this trench, could be engulfed by this this collapse. It's next to a residential structure, so that's a problem, as I mentioned, about causing the trench to collapse. There's no protective systems or sloping in use. And the ladder's at the end of the trench, so he's got a long ways to go for egress to get out. So tools and machinery, when we're talking about machine guarding and guarding you as far as tools and flying debris and that sort of thing, we got to make sure that you don't remove the guard from a tool except for cleaning or changing a blade or bit. But that if that machine has a guard, that power tool has a guard, you have to be using it. when you're finished with the cleaning and maintenance, make sure you replace the guard right away. And you can't rig up that tool to wedge the guard open either, because that's defeating the safety feature of that tool. You know that OSHA can issue a citation to you. Generally, it's going to be the General Duty Clause, Section 5A1, for not following the instructions that came with the tool. The instruction manual that comes with every tool is considered a legal document. So guarding and attachments are designed for your specific tool or machine. Use only the attachments that are specifically designed for that tool or machine. So here's an example of a saw that's used for cutting masonry block. And you see a bunch of masonry block here that's being cut. When the belt breaks or flips off, and you got to take the guard off to replace the belt or put the old belt back on, you've got to put the cover back on. They don't have the cover anywhere in sight here, and so that becomes a problem because it's right near your body, your head, your chance of that belt in a nip point of maybe taking off hair or grabbing clothing is very high. So you're not allowed to use that tool until you've got that guard back on that's completely enclosing the two pulleys, the pulley on the motor and the pulley that's actually rotating the shaft for the blade. So that's a big issue. So unguarded belt and pulley, so the worker can get hand or clothing caught in the running nip point, right at that pulley that's right next to the shaft of the blade. Okay, here's some gears, and so these gears need to be guarded in some way so that you can't get near them when it's in any kind of operation. So that's what they're talking about. Gloves can get tangled up, clothing, sleeves of shirts, jewelry, other loose-fitting clothing can be hazardous if caught in the moving parts. So any moving or rotating parts, there's a hazard there of being a victim of a caught between. Most types of heavy equipment have pinch points at various places. So here I've got like 4 arrows on this diagram pointing to pinch points that can be a hazard when you're servicing the equipment. And typically with a track hole like this and many other kinds of equipment, they have certain grease points that have to be serviced very regularly, oftentimes more than once a day throughout the workday, with grease guns and stuff like that. Any type of moving equipment can trap and crush a worker. So here's the one scenario showing the idea of the counterweight on the back of a crane being the thing that's going to come closer to that wall than anything else. And if you're trying to make a shortcut behind while they're working, you might be pinned. And how about this? This guy's not an amoeba. If it slices them in half, there won't be 2 of him. So yeah, any kind of a hazard like this, whenever you jack up a load, you can lift the load with hydraulics, but you do not trust it. You have to support the load with something else. So you do not work between the frame and the dump box of a truck. It's until that truck box is blocked up. And there's many other things that we jack up, from cars to heavy concrete girders and steel girders. You don't just jack it up and trust the jack. You've got to support it with some kind of dunnage, cribbing, blocking of some kind. Here, apparently somebody's directing him to come a little closer and a little closer. And once that machine bumps up against those kneecaps, the guy will never work properly again. So the employee could be caught between the track of a dozer and the wall, and the dozer won't be hurt at all, and neither will the wall, but your legs will feel it. So just in review of these 2 topics we're dealing with here, struck bys and caught in between hazards, and review and kind of emphasizing a few other things here. These are all critical things on these next couple of pages. To interlock stacked materials, we place the objects at right angles. If you think of stacking bags of concrete mix on a pallet, each level will be rotated in a different direction so the bags will lap over top of each other, kind of like bricks in a wall, So that's an important principle. We place the objects at right angles to each other as we go up, as we stack from layer to layer. The next point, the maximum height to base ratio of any stack of materials is 4:1. So that means you can go up 4 feet if you're stacking something that's 1 foot wide. In theory, that's a maximum number. Doesn't mean it always works, but it's the maximum. The next point, protective guards protect workers from being caught in rotating or moving parts on power tools and machinery. And so the protective guards of a circular saw, for instance, protect you from that lower from the lower part of the blade. So you got a retractable guard on the bottom of a typical circular saw, like a skill saw. The last bullet on this page, equipment rollover. The equipment rolling over is what we're talking about here. So equipment rollover is the most common cause of death for equipment operators. So people that are operating the track hoe, the forklift, their most common fatality is from the equipment rolling over. Well, here's the thing, is that a seat belt is always included in that equipment, and they're supposed to wear it. And the whole idea is a rollover canopy, a rollover protective structure. What we abbreviate that as ROP or ROPS. That is meant to be kind of the roll cage to protect you when the equipment rolls over, but it only works if you're wearing the seat belt so that you stay within that canopy, that roll cage. So that fundamental that you wear a seat belt when you're operating equipment all the time. It's not for crashes, it's for the rollover that you need it. Anyway, so that's an important example of a caught in or caught between hazard. Cave-ins typically are caught in between hazards. They happen suddenly with little warning. They occur in trenches between 5 and 15 feet deep. Now, trenches are shallower than that. They can be much deeper than that. But on average, the most common cave-ins happen between 5 and 15 feet. And that's a number that you need to remember for a testable point near you. Okay. Then the next bullet, trenches that are over 4 feet deep. Well, an exit, usually a ladder, must be within 25 feet of each worker in the trench. That means if you have ladders every 50 feet in the trench, a long trench, you'll always be within 25 feet of a ladder. And by the way, if you have, OSHA says 25 or more people in the trench, then you have to double up the egress. And that's really a minimum standard. You know, you shouldn't have to take a number to get out of a trench in an emergency. Third bullet on this page, spoil piles of excavated earth, that we were talking about a moment ago, must be kept back from the edge of an excavation. And here's the important testable point, by at least 2 feet. Actually, everything from your lunch bucket to the lumber pile, everything has to be kept back at least 2 feet from the edge at the top of an excavation. So certainly the spoil piles, the piles of dirt, qualify in that same way here. And the last bullet on this page, built-in place trench protection. So a trench protection designed to prevent trench wall cave-ins, we call that shoring. So there's a terminology here that's a little confusing. But yes, it's a built-in place structure. I call it that. But the testable point can just say trench protection. And you're supposed to know that it's a protective structure. We're talking about shoring. Trench protection. It is considered the same as shoring, whereas the trench boxes or trench shields, they're considered more temporary, and so they're kind of in another funny area in between sloping and protective systems. But anyway, so just be careful on that. So when you see the word trench protection, we're talking about shoring. And what is shoring? It's the stuff that we build in place as opposed to something we drop in the hole like a trench box. So, a couple other questions. Just look at these few here to see if we kind of can find anything else here. When working near machinery and equipment such as cranes, where should you never stand regarding the load? Beside it, behind it, below it, in front of it, below it. Okay? So never below it. Okay, so that would be example here. And the next question, when there is a threat of flying objects, what personal protective equipment, what PPE should you wear? When we're talking about flying objects, the respirator won't help, the hearing protection won't help. It's really the bottom choice. It's hard hat, eye, and face protection. Next one, when operating a vehicle and approaching an equipment operator, where should your vehicle never be? Well, when you look at all these choices, blind spot, beside them, behind them, anything that's a blind spot, so that's got to be it, no matter where it's at. Okay, and I think we're here, maybe this is the last one. When a vehicle is operated indoors, what in the exhaust can kill or sicken anyone in the vicinity unless there is good ventilation. Well, you start mentioning all these things. The top one, the most poisonous one of the bunch here, is carbon monoxide. And it's the clue because that's the gas that is emitted that's dangerous when a vehicle is operating indoors. So there you go. Oh, yeah, one more here. How much soil can put enough pressure on your lungs to prevent you from breathing? Remember what the number was? It's an important testable point. It's 2 or 3 feet. So 2 to 3 feet. So that's the range you need to remember as a testable point. So that's enough about struck bys and caught in between hazards to help you succeed on your test.